Hello guys, I hope you all are doing good. I'm Vaishali Kikan and we are discussing the electronics engineering. Today in this video we are going to talk about the full wave bridge rectifier. In the previous videos we had already talked about the half wave rectifier and the full wave rectifier. Now the second type of the full wave rectifier is the bridge rectifier that we are going to learn in the today's video, right? So this is the structure of the full wave bridge rectifier. In the half wave rectifier I was using one diode. In the full wave rectifier I was using two diodes. Now here in the full wave bridge rectifier I will be using the four diodes. So here in the full wave rectifier, the center tap transformer I was using, which was costly and it was having the high peak inverse voltages as well. I hope you understood the disadvantages also about the full wave rectifier. In the last video I talked about it. So now I can overcome this disadvantage using the bridge of the diodes. So instead of center tap transformer, I have used this bridge of the diode with simple step down transformer. This is my simple step down transformer that I was using in the half wave rectifier as well. So this is not much costly and I can simply use it. Here I am using four diodes which are connected in the bridge forms, two diode connected at a time, and which is going to give me the full wave rectification. At a time I will be having two diodes in the forward bias and two diodes in the reverse bias, and thus I will be having the output current at both the positive half waveform as well as the negative half waveform. So this is how it is going to generate the full wave at the output, right? So now here you can see this is the operation of the circuit. Now here you can see we have the transformer. This is a step down transformer and we are supplying the positive half cycle. During the positive half cycle the current is flowing over here and the current will make this diode D1 to be forward bias, diode D4 will become reverse bias. Now D3 will also become reverse bias. You can see we have made an open circuit over here, and this diode D2 will become forward bias and it will conduct. So now how the current will flow? Current will move from here, it will move through the diode D1, move from here, move to RL, and then it will move like this, right? So this is how it is going to have a full path in this circuit, right? So now I hope you understood how the current is moving. So from here it will move here, then here, and it will move then to the terminal B. In the positive half cycle, when I have A as at the higher potential than the B, so diode D1 and D2 will become forward bias and D3 and D4 become reverse bias, thus they become open switch. Diode D1 and D2 will conduct, right? And this is how I will be getting current at RL. Whenever I am getting current at RL, the output voltage would be there, right? So input voltage will be equal to the load voltage. Now coming to the next half cycle, the negative half cycle. So during the negative half cycle, diode D3 and diode D4 will become forward bias, diode D1 and diode D2 will become reverse bias. So how the current is flowing? The point B is at positive terminal, so current will flow from here to here, then here. Diode D3 is forward bias, it will conduct the current. So here, from here it will move to RL, and from RL it will move here, and from here it will move here, and from here then it will move towards diode D4, which is again it is conducting, it is in forward bias. From here it will move to the terminal A, and this is how the current has made the full path, and this is how we can get the current across RL, due to which I will be getting the voltage generated across RL. So I hope you understood clearly how in the positive half cycle as well as in the negative half cycle we are generating the output load voltage, right? So the waveform would be something like this. So this is my VM, the maximum voltage. This is my secondary voltage that we have, right? So secondary voltage at the secondary terminal of the transformer, which is my input voltage. Now the load voltage will be the voltage which is occurring at all of the cycles, right? So load voltage will be there, and here we will be having diode D1, D2 forward bias, and for the negative half cycle I will be having D3, D4 forward bias. Here again for the positive half cycle I will be having D1, D2 forward bias, right? Now the load current will be having the full wave characteristics. It will be having maxima, right? So it will be not 0 in between pi to 2 pi, it will be having maxima in between all of the values, right? So now coming to the diode D1, D2. The diode D1, D2 is conducting only for the positive half cycle. So it will be conducting from 0 to pi and from 2 pi to 3 pi, right? So this is how from 0 to pi and from 2 pi to 3 pi I will be getting the diode D1 and D2 conducting, and we will be getting current through diode D1 and D2. Current through diode D3 and D4 will be there only when we have the negative half cycle from pi to 2 pi, right? So now this is how we will be having some peak inverse voltage. In the forward we have some leakage current which we are ignoring. For the ideal conditions we will not be having the leakage current, but practically we have some leakage current as well, and this is the minus Vm which represents the peak inverse voltage. Now coming to the analysis of the full wave bridge rectifier parameters. What all parameters here we have? We have all of the parameters which are same as the full wave center tapped rectifier. So if you have studied them, now you know all of the parameters of the full wave bridge rectifier as well. So we have same analysis as full wave center tapped transformer rectifier circuit, but diodes forward resistance is twice as the two diodes conduct in the series. Here if I talk about the current path, we will be having two diodes in the series, so we will be having 2 RF in the forward resistance. So wherever you were putting RF, you have to put 2 RF, right? It is hardly going to make any changes in the various parameters. So turn on resistance is 2 RF and the peak inverse voltage is Vm. Now here we will be having the transformer utilization factor which was same as the full wave rectifier center tapped, so it will be equal to 81.1%. Right, now coming to the advantages and disadvantages of bridge full wave rectifier. What are the advantages? First of all, I am not using the center tapped transformer which was costly, right? So now the transformer is not even compulsory. We can use transformer if it is available or we cannot, right? So it is suitable for high volt appliances as peak inverse voltage is equal to Vm, only it is not equal to 2 Vm, right? The core saturation will not take place because we will not be having any constant voltage, right? Now coming to the disadvantage, it will be needing 4 diodes. This is the only disadvantage that we have. So I hope you understood each one of the things that I have discussed in this video. If you have any doubt, you can put the doubt in the comment and I will be trying to resolve your doubt as soon as possible. I hope you like this session. If you like it, please push the like button, subscribe to the channel, share it with your friends and also give me your feedback. Thank you so much.